Hey, once upon a time, there was a software development team that was struggling with latency issues on their Kubernetes clusters. So they had tried everything they couldn't think of it actually, but nothing seems to be worked. That is until they discovered 10 hacks that could help them to improve their cluster performance. So, so let's get into the video. So today we are going to discuss about something called the latency issues, and I'll be providing a 10 hacks how to optimize this kind of latency issues. So we can quickly get into the how many hacks that we have. Okay, so hack number one: increase the number of nodes in your cluster, and this will help distribute the workload and improve the performance. Okay, so there are the commands that I have posted here, and you can check out the commands. And if your Kubernetes cluster is having running with the less number of nodes, probably you may need to add a lot of nodes. Okay, this is hack number two. Optimize your pod scheduling. Make sure your pods are scheduled onto the nodes with the necessary resources and available to run them efficiently. What exactly it says, like if you're scheduling some pod and you are the resources, I mean to say that node should have the proper CPU and memory. If it doesn't have those resources, your pod may get into the pending state. It won't schedule it properly. There are certain advanced scheduling the methodologies are there in the Kubernetes cluster. Probably you may need to check into that. One of them, not one of them, a lot of them are there. I will list out like node affinity, pod affinity, taints tolerance, spread scheduling, node selector, pod resource, request limits, and all those things are there. Probably you may need to check out all those options. Okay, the hack number three is all about the CNI. Okay, it's the plugins, CNI plugins that you have to use it. There are certain specific CNI plugins which just helps to reduce the network performance. Sorry, to optimize the network performance and reduce the latency. Okay, you have to use something called persistent volume climb, or you're using a persistent volume climb. Yes, if yes, then you have to look into it. You have to use a dedicated storage solution. If you are persistent volumes, consider using dedicated storage solutions like Ceph and GlusterFS to improve the performance. Basically, if you're using a PV persistent volume or PVC persistent volume climb, and you have to use this kind of the open source the dedicated the storage solutions, it will improve the it will reduce the optimize the latency and improve the throughput. Okay, you have to check out your container images. Basically, you have to make sure the images are optimized for size and you are only including the necessary libraries and dependencies. Okay, what it means to say is your image file should not be in huge size. Okay, it has to be very less, and you should not add a lot of files into your container image. You have to use only the use of what is the required files and what is the required the solution that you're trying to run it, and you should not add a lot of things, and you should not do more than 1 GB or 2 GB something. So it will also create a lot of issues. Use lightweight base image, minimize dependency, use multi-stage build, remove unnecessary file, use registry, implement caching, run vulnerability scans every day. Okay, this is something like you have to check out. Use resource limit and request. This ensures your pod have the necessary resources to run efficiently. So basically, you have to put up what I can say. It's a belt, or you have to put a limits. Your pod should use this much of CPU, this much of memory. If it used more than then your pod will should have to crash it automatically, and it has to restart once again. So this kind of things are there in the KTS. You can leverage it, and you can reduce the latencies. Okay, this is all about the distributing the load. Use the load balancers like Nginx and HA proxy, and it will help you to distribute the traffic even across all the nodes, reducing latencies. Okay, this is all about the monitoring. Okay, you have to monitor your cluster. You have to check out the CPU. You have to check out the memory. You have to check out the disk, how much exactly it is consuming. So based on that you have to take the steps to optimize that entire cluster solutions. Okay, this is all about the caching. Caching is it's one of the most important feature. So there are some solutions called REDIS, MEMCACHED. Caching can reduce the number of requests to your backend servers, and it improves the latencies. Okay, so what exactly it says, like you can keep the the data instead of putting onto the MySQL, instead of the request going eventually to the MySQL, you can put some cache data into the Redis or a Memcache. Instead of going to MySQL, it will go to the Redis and it will give the data. So the latencies will get reduced somewhat. Okay, this is all about HPA. What it means. Okay, if your pod is having a lot of CPU usage, or the memory usage is very high on your pod, and you may require to add one more pod onto your cluster on your namespace. So by using HPA, it will automatically scale up your pod and automatically scale down the pods. Okay, basically how we have in ASG in AWS, the similar kind of uh, the what you can say the feature in KTS. By using it's a completely metric driven. By using the metrics, it will scale up and it will scale down. Okay, that's all I have. Or probably I think you might have enjoyed this particular video. So if you like this video, please do hit like button. So if you want to share this particular video, you can go ahead and share it. So create a good karma. I'll see you on the next video. Thank you so much. Thank you for watching.